Here's another look at total internal reflection, and I just want to show it to you because this is very important to telecommunications because it's how optical fibers work. So to make an optical fiber that can carry light, all you really need is a thin rod of glass or any dielectric that's not going to absorb the light. So if you have a little bit of glass, it can be very thin, then the light will come in, and if you launch it at the right angle and engineer it correctly and everything, as long as you keep these reflections at a higher angle of incidence than the critical angle, you'll get 100% reflection and you won't lose the light in the ideal theoretical physics world. In the real world, they put other stacks of dielectrics on here and claddings and do all this work to minimize the losses in a fiber. But the fiber can even bend over sort of a macroscopic radius of curvature and you still don't lose the light. So this is how you can have light pulses go kilometers through complex regions with an optical fiber. So I could show you an optical fiber, but it's basically black magic. It has a cladding around it, and you may not believe me, but that's really what's happening. So instead, I'm going to show you one with my milky fish tank. So right now, the milky fish tank is empty, and the laser is going in through the wall here, and I've actually drilled a small hole here. Okay, so there's a little hole that's letting the laser out, and as it comes out, it definitely propagates along. Just get a little smoke so you can see the laser comes out, and there it is. So there you can see the beam. It goes all the way across. So the beam is going straight, as you would expect. Let me get rid of this. Okay, so straight beam. I just wanted you to make sure you see that there's a beam there. So what I'm going to do is pour my milky water back into the fish tank and probably make a mess, and we're going to make a small optical fiber. So here you can see, I'll catch a little here, that now the laser is getting trapped inside this curving little column of water coming out. And as long as the little column of water is nice and smooth on its edges, it holds on to the light. But as it starts to scatter away, or as the smooth column of water breaks up, the light scatters out. So you can see right there, it's starting to break up, the light's coming out. Here, it's holding the light in, and it's basically making the light curve because it's following it like an optical fiber. But this is one where you can tell you really know what it is. It's not a secret fiber with secret cladding on it and everything. So I just wanted you to see it this way. If I break it up earlier, then you can see the light comes out earlier. So it really is carrying the light. And you could very naively think it's storing the light in the jar, but of course it's not storing the light in the jar. So there you go. Not the most efficient or practical optical fiber in the world, but it is an optical fiber.